Welcome today for this new web event. Sorry for the little delay to begin this event, but now let's jump into the topic of today. The Meet the Expert subject of today will be the Physique-based sensor pack in SCANeR Studio. So I'm Paul Rigaud. I'm working for AV Simulation as a pre-sales engineer since 3 years now. My goal is to be able to help the new user of SCANeR Studio to do what they want to do with our tools, to produce demonstration, tutorials, etc. So like you can understand, the goal of today is to give you a good overview of what is available in this Physique-based sensor pack. And hopefully you will want to try this new solution and these new tools. I'm also with Pefer Ludovic, one of my colleagues as a pre-sales engineer. So if you have any question, please feel free to use the chat of the event. In case you want to ask this question as an anonymous participant, no problem. But in this case, can you please also send us an email with your name so we can answer you by email to your different question. And we are also with Pierre-François Perrat from Oktal SE, but unfortunately, it's where we have the little technical issue because it seems that it's hard for Pierre-François to join the event and to talk. So Pierre-François is here in the event, but he has problem to communicate in this event. So just to let you know that Pierre-François Perrat from Oktal SE is also in the meeting. So if you have any kind of more advanced question or question about Octal SE, it will be one of the topic of today. Feel free to use the chat and we will see also with Pierre-François how to answer you. So let's jump into the topic of today. So this Physique-based sensor pack, first of all, what is important to notice is that this Physique-based sensor pack comes in addition of the foundation pack. As you probably know, the new licensing package of SCANeR Studio make the life way more easy to design the correct configuration of SCANeR Studio. So what's happened now is that you have the foundation pack, which is the self-sufficient pack, is the basic pack of SCANeR Studio. And depending of your application and how you want to use SCANeR Studio, you can actually choose which pack will, I would say, match your needs. So in a previous event, I think it was last month, we saw together the AD-ADAS pack. The AD-ADAS pack presentation. So today, I'm sorry if you miss it, the replay is available on our YouTube channel, but we will not talk about this AD-ADAS pack. We will only focus on the Physique-based sensor pack. So you will tell me, I think you could ask, okay, but what is the main differences between these two packs? So to do that, let's jump into the topic of the sensor in SCANeR Studio. So as you can see at the right part of my screen, when you take a real sensor in the real life, what's happened, what is important to notice is that you have a signal propagation from your sensor and to your sensor part, and then you have a pre-processing aspect inside a sensor, which means that we will kind of translate the information of the signal propagation to, I would say, a useful information for your sensor. For example, for a camera, it will kind of convert the light and the brightness sent by the signal propagation to, I would say, useful information like a voltage, for example. And the goal of the new sensor, of the smart sensor, is at the end of the processing of this different information to have an object list to feed your AD-ADAS system. So you want to have a list of information about the detected target, the different speed of the elements, the position of the different elements, etc., etc. So starting from a real sensor, what we have designed in SCANeR Studio, we have kind of split the simulation scene in three big parts. Is on the left. So when you take a simulation, when you take an environment, you have three parts. So the first one will be the 3D. So the 3D is kind of easy to understand. What is this layer, if we call it layer? The 3D is like the different geometry of the element of your scene. If it's made of triangle, what is the general shape that you will see with the 3D. Another layer that is very important is the semantic layer. So the semantic layer, it will contain all the logical information of your scene. So let's take the example of a road sign. The 3D world will be the shape of the road sign, and the semantic layer will be the logical information contained in this sign. So for example, if the speed limit is 50 km/h, for example, that's the semantic layer. Also, we can see the world, the simulated world, with also the physics layer that will kind of add on top of the 3D world model physical properties on your different elements. So the scene is split in these 3 different layers. And regarding which layer we are going to use, we are going to have different level of sensor in SCANeR Studio. So the first one, the level 1 ideal model, is the one that I will say it's a little bit the historical solution with SCANeR Studio. Is the one that I think most of you know with our radar, or GPS, or camera at level 1, which we can say they're like perfect sensor. Why we can say they are perfect sensor? Because what is important for this level 1 sensor is to send a very accurate object list. So you want to feed your ADAS system, you want to have a lot of information about the different elements of your scene in SCANeR Studio. Of course, we can add on top of it some kind of statistical noise model to kind of perturb the detection. But as you can see, we don't take into account all the physical properties of your scene. All the physics-based properties of your scene will not be taken into account in the level 1. So you will just take into account the 3D and the semantic layer to send a very big object list in SCANeR Studio. So the level 1 is the ADAS pack. So sorry, I'm not going to speak about that today. Us, we are going to focus more on the level 2 and level 3 that are like, I would say, more new to SCANeR Studio. And that, so the physics-based sensor is actually made of this level 2 real-time physics sensor and this level 3 full physics sensor. We'll go more into the details about what is level 3 and what is level 2. Just to give you a first idea, I will say, the level 3, as you can see, is using not the semantic layer, but the physics layer and the 3D world model. What is very important with the level 3 is the full ray tracing. It's to have a very accurate signal, a raw, I would say, raw output for your sensor that will take into account these 2 different layers. So we are a little bit at the opposite of the level 1. At the level 3, we will give you the full physics signal and a very raw data that you will need to process thanks to your different technology. That's the level 3, a little bit the opposite of the level 1. In between, we have the level 2. As you can see, we take into account exactly the same layer, so the 3D and the different physics properties of your scene. But we will see more into details that we are making kind of a generic processing on the signal sent by the sensor, which means that you will not have access to the raw data. You will already have a kind of a list of plots that you will still need to process to see more information. So we will see more into details, but just to tell you that we are going to focus on the level 2 and the level 3 today. So unfortunately, it's a little bit with the technical issue. We cannot hear the presentation of Pierre-François because just to let you know that the level 2 and the level 3, because of all these physics-based properties that we need to take into account, we have worked at AV Simulation with the Oktal SE company, which is our sister company. So Oktal SE and AV Simulation are part of the Sogeclair group. Sorry, so we are the sister company, and their specialty at Oktal SE, it's really code software for physics-based sensor. They have big experience in all the physics-based sensor simulation since a lot of years. Us, we have the knowledge in the automotive industry and in the simulation. They have the knowledge in the physics-based sensor simulation. So what we have done is that we've associated our 2 technology to make this product available. So for your question, and I think it's very important to know that we are really using all their technology, and we are really, I will say, using one of the best tools available on the market with the SE Workbench to use all their technology, all their development directly integrated in SCANeR Studio. So just for Octal SE, just to go a little bit more deep on the subject, as you can see, some of their clients, they're like working a lot, as you can imagine, Octal SE in the aeronautical airfield, and also in all the defense, the French army, etc. It's big customer. It's very big company, and as you can pre-imagine, this kind of company, they really wants to rely on tools that have made a proof, that have been tested and validated for a lot of years. And it's exactly what Octal SE has done for the physics-based simulation. So, like I said, unfortunately, Pierre-François could have told way more on this different subject, but please, if you're interested to know more about Octal SE and what they do, you can see here their website, and you can send us an email if you want to learn more about Octal SE. What is important, I think, as a kind of a recap, is that they have 30 years of experiences in this field, and we have really worked together as sister company to put together this product and really to bring, I will say, the best of that technology inside SCANeR Studio. So you are going to tell me, great, that's a very good things to know that Octal SE is integrated with SCANeR Studio, but how it works, how it's really integrated in SCANeR Studio. The answer is very simple, it's seamless integration. So you know SCANeR Studio, you know how to create a scenario or to configure your sensor, the different tools that you already know. If you use the level 2 and level 3 sensor of SCANeR Studio, we will use in a very seamless way the different tools of Octal SE and the SE Workbench solution. That means that you don't need to launch any other type of software. You don't need to make any kind of co-simulation when you will use the level 2 or level 3 sensor inside SCANeR Studio. Everything will be done automatically. You don't need to launch anything on any other things or need to have a special training on the subject. It will be exactly what you know. It will be based on models. It will be based on sensor modules and etc. So you don't need to launch any other type of solution. Everything is directly integrated, and we really incorporate the Octal SE technology thanks to, I would say, our special relationship with Octal SE. So the physics-based sensor pack, what is included in this pack? So first of all, I think it's interesting to know that is, as I mentioned at the beginning of the meeting, it comes, I will say, in addition of the foundation pack. And in the foundation pack, since SCANeR 2021, as you probably know, we have a new rendering engine that is based on Unreal. And because we have this new rendering based on Unreal, we have by default with the foundation pack a real-time physics-based camera. Let me just explain to you why. It's because Unreal, you can associate physical property and physics properties to your different element of your scene. And because the camera of SCANeR Studio can use this 3D rendering of Unreal, we actually, I would say, take into account the physics properties of your scene with this camera. So that's not part of the physics-based sensor pack. It's by default with SCANeR Studio. What comes with the physics-based sensor pack is, first of all, let's say that tomorrow you want to try, or after this presentation, you want to try this pack. The first thing to do will be to decide which model and at which level you want, which, I would say, sensor at which level you want to have access. So you can make a choice or not. It means that if you want to use a real-time physics-based radar at level 2, it's possible. Then you can choose to use or not a full physics radar sensor, and or also the real-time physics-based LiDAR. So you can choose which one you want to use or not. You can, of course, use the three, and you can also, of course, choose the quantity of this sensor that you want to use. For example, in the same simulation, you can have 2 times the real-time physics-based radar at level 2 and 1 LiDAR at level 2, for example. That's definitely possible. Also, what is included in this pack it's some kind of tools to help you to begin to use these different new radar and new sensor in SCANeR Studio. So we, by default, you will have access to a new terrain, this highway scene. What is important to know, and I think you already kind of understand why it's important, is because this level 2 and level 3 sensor take into account the physique properties of your scene. It will be important to characterize your terrain of SCANeR Studio. So we have the possibility to do it directly in the terrain mode. We will see that a little bit after. But if you don't want to do that, you just want to launch a scenario without putting any kind of special materials on your terrain, we give you by default a highway scene, a terrain that is fully characterized in SCANeR Studio. We also give you 4 vehicles that are also fully characterized. That means that we have applied on them special material with special physics properties. So by default, we give you 4 of them. And of course, if you want to add and increase the list of fully characterized vehicles, that's definitely possible. Also, you will find a new module in your configuration, the sensor OSE module. So this module is a little bit, I would say, the sister of the sensor module that you know for the level 1. It will work exactly the same. So the sensor OSE module will manage the level 2 or level 3 radar. So you will just have to add it in your configuration of SCANeR and just launch it, and everything will be automatically managed by this module. And we also give you 3 scenarios to help you that will use the previous element, the terrain and the fully characterized vehicle, to give you a first idea of how it works and to also just give you an idea of the results of the different simulation. Then in the terrain mode, like I explained to you, we have the possibility to define material with different physical properties and to assign to the different elements of your scene these different materials. So for example, if on the road you want to apply a special type of material with different physical properties, that's possible. Then if you want to use a road sign with a different material, like a more metallic material, for example, with different physical properties, that will be definitely possible to do it directly from the terrain mode of SCANeR Studio. And to go a little bit further, you can actually externalize this physical terrain, and you can then after use it in the Oktal SE tool for the people that want to go a little bit further in the physical properties and they want to really, I would say, change at a very deep level the physical properties of the material. You can externalize your terrain, open it in the Octal SE tools, and change the different properties of your terrain. So as you can understand now, you will probably need to make a choice in the which sensor you want to use. So let's jump in the presentation of every sensor. So we are going to begin with the real-time physics-based LiDAR. So I think the best way to understand what is this new LiDAR at level 2, it's to understand the difference with the LiDAR at level 1. So we have new features with this LiDAR that will really make it, I would say, a more powerful LiDAR inside SCANeR Studio. Because first of all, with this LiDAR level 2, what is possible is to change the intensity of the laser beam. Also, as you can probably understand after this presentation, we will also take into account the different properties of your materials in your terrain. So the radiance of your LiDAR will be computed for each ray, and we will take into account the different physical properties of your scene. Also, for the beam of your LiDAR, you will be able to use non-perfect beams. So you can, for example, import your own shape of beams. We will take into account also the laser impact spot shape. So let's say that, for example, you have a vehicle in front of you and also a tree. If the beam first hits the tree, its impact shape on the car will be a little bit different. So that will change. And also because of this physics base and all these properties, we will also take into account the echoes. So for example, if you have 2 vehicles nearby, you will have an echo of the signal of the beam between these 2 vehicles, and you will have these echo parameters in your simulation. But at the end, with all these new features, we still keep, I would say, the main philosophy of SCANeR Studio. It's mean that all these messages sent by your radar light, from your LiDAR at level 2 will be also available in the SCANeR Studio network. So in the simulation bus of SCANeR, you will have access, so you can actually have access and read this information through our different API. Maybe just a little video of the result. This result has been made with the sensor viewer module of SCANeR Studio, which really allow us to have a very good overview of the output of the LiDAR in real time. And as you can see, we have a way more complex shape for the beam, and we also take into account the different properties and physics properties of your scene. So let's jump now for on the radar. So I'm not going to talk about the radar at level 2 first. I'm going to talk to you about the radar at level 3, and hopefully you will better understand the difference between the radar at level 2 and the radar at level 3. So the full Physique radar sensor at level 3, first of all, if you want to use it, the first, I would say, step you will have to do is to, a bit like the other type of sensor, it will be to modelize this radar in SCANeR Studio. So to do that, we give you access to a lot of different parameters for your radar to be able to really modelize your sensor. So for example, you will have access to the possibility to change the frequency, the aperture, the resolution, and the different properties of the antenna of your radar at level 3. What is very important for the radar at level 3, and as we have seen at the beginning, the level 3 is really a full Physique based sensor. It means that this radar will benefit from the electromagnetic full ray tracing. So we calculate the electromagnetic field wave propagation by doing a full ray tracing. So this full ray tracing will produce electromagnetic field at the entry of the sensor. This ray tracing is computed, and we take into account all the multiple reflection and all the interaction that we will have between the target and the environment. Also, at this level of modeling, what is important is that we are able to simulate the coupling of the different elements of the scene. So that's a very general description of this full ray tracing, but what you will have inside SCANeR Studio as an output, the output will be a raw Doppler signal. That means that you will have access on the information on the Doppler speed and the range of the targets as an output for the radar level 3. So what it looks like, it's what you can see at the right. So you have a raw data. It's a Doppler signal, it's very raw, and it's not in real time. So the level 3 is not in real time because we really take into account all this very complex interaction between the ray tracing and the environment. We are not able to make a real-time application, so it's not in real time. But I will say the main benefit is that you really have the raw data, and you can really after, I would say, interface your signal processing on this raw data to really see how your signal processing is done on the radar. All the output, so this different raw Doppler map, will be shared in the shared memory of SCANeR Studio. That means that you can have access to them, for example, through our different API. And also, you will have access in the SCANeR Studio recorder folder. You will have access to a video of the output of the different images of the output, 1 image per frame, and 2 text files for each frame. So that's for the level 3. So we will see after what are, I will say, our main application with that. But I think as a little recap, what you need to understand is that it's you have a lot of parameterization of this radar. We are doing a full ray tracing, and we give you as an output a raw Doppler signal, a very raw data. And on top of that, you will have to, I would say, interface your signal processing on this output. For the real-time physics-based radar sensor, so what are the differences with the level 3? So it's not on the parameters of the radar, because you can edit the same parameters than the level 3. So the aperture, the resolution, the frequency, everything that we have seen before, you can really edit exactly the same parameter for the level 3. One of the big difference with the level 3 is that we are using exactly the same electromagnetic retracing engine from Oktal SE, but we use an accelerated version of it. When I say accelerated, is that we optimize some calculation of this retracing. So we simplify the geometry of the scene, some material, and we have an accelerated version of the retracing engine, but it's exactly the same than the level 3. So it will also take into account the different properties and physics properties of the scene. The other big difference with the level 3 is that it integrates this level 2 a generic processing of the information, which means that as an output, you will not have access to a raw signal. You have access to a list of plots, as you can see at the right of my screen with the little animation. So you will not have the raw data with the Doppler map of the level 3. You will already have a list of plots. And for each plot, you will have the different information, like, for example, the range, azimuth, intensity, elevation, and speed. So as you can see, because we are doing an accelerated version of the ray tracing, and also because we have the generic processing, the big difference will be the output that are not a raw Doppler map, but this list of plots, and also we will be in real time. So the level 3 was not in real time. The level 2 is in real time. Also, one difference is that all these plots, so the different information about the plots, so the intensity, elevation, and etc., will be accessible through the SCANeR API, because they are in the simulation bus of SCANeR Studio. So after that, you can use these outputs, this list of plots, to feed your ADADA system, for example. And a little bit like the level 3, you will have access to a video of the radar output. You will have one image per frame, and you want one text file that is just a recap of the different information about the list of plots. So this generic processing, how it works? What is this generic processing that allows us to have a real-time application? So let's go back to this very generic processing. So let's start from your scenario that uses a specific terrain inside SCANeR Studio. So what we are doing is that we are doing electromagnetic retracing. So we are going to send electromagnetic signal in the scene. We launch a lot of rays, more than on the illustration. So what is going to happen, because we launch a lot of rays, is that we have, I would say, millions of different contributors in your scene. So with these different contributors, we kind of accumulate them. So we take all the contributors that have, I would say, not a big contribution, and we are going to accumulate them into these cells to just have, I would say, a finished list of plots inside the simulation. So you have all these contributors, we accumulate them, like the one that have a low intensity, and at the end we have a list of plots, and we give you this list of plots. What is important to notice is that, as you can see, for example, on this illustration, in this little scenario, I have only one vehicle in front of my vehicle. But even if I only have one vehicle, I have multiple plots. Why? It's because we have all the echo effects in the simulation. So for example, in this scenario, I have a guardrail between my vehicle, and I have a guardrail just at the left of my target vehicle. And my contributor, when I'm going to launch my rays, of course, I'm going to have echo parameters and ghost effects between this guardrail and my vehicle. So I will have more plots than the actual number of targets in my simulation. The goal is after for you also to still, I will say, do some SCANeR processing on this information to really extract the correct plot with the correct information in your simulation. So now, what do you need to use depending on your application? So first of all, just to let you know, and because we have seen that together, you have access to the same parameters when you want to modelize your sensor, your radar sensor in SCANeR Studio. So that you just need to parameterize your model. Then you can choose if you want to have a level 2 or level 3 radar. So that's exactly the same parameter. You just choose between level 2 and level 3. Just a quick recap. The level 2, because of this accelerated ray tracing and this very generic processing that we have seen, it will give you as an output a list of plots. Then, of course, like we said, you will still have to process this list of plots to extract the correct information. But I will say the information are more easy to filter to have the good information. For the level 3, we don't do any kind of processing. We really send you this raw data with these different Doppler maps. So if you want to have access to all the radar processing, and if for you the realism count more than performances, I will go with the level 3. In all the other cases, you can use the level 2, because I think in the other cases, what is important for you is that you want to have a radar that use the same technology with the ray tracing and everything, that will take into account the physical properties of the scene, but it will be in real time and it will send you a list of plots. To show you a little bit what it looks like in SCANeR Studio, and just to show you how easy it is to use this tool, I'm going to show you how to do a simulation, first of all, with a radar level 2. So as you can see, I have my different vehicles that are fully characterized, so I can use them in a scenario. Then also I have access to the fully characterized terrain in SCANeR Studio. And I have my sensor OSC module inside my SCANeR Studio configuration. So I'm going to open one of the scenario by default. So it will be for the radar at level 2. So as you can see, it's a very simple scenario, one ego vehicle and two target vehicle. If I edit in the same way than for the level 1, I can edit also the sensor configuration. So as you can see, I can see my Physique radar, Physique-based radar. I can edit its properties. I can change the different properties of this radar. So everything is very graphical like for the level 1, but the parameters, of course, are very different than the radar at level 1. I can also configure the output, and as you can see, I can choose if I want to be at level 2 or level 3. So in this first scenario, I'm going to use a radar at level 2 to show you the output and what it looks like inside SCANeR Studio. So I'm going to launch my module, my sensor IC module. I'm just going to display the debug view of this module. As you are used to, you just need to launch this module a little bit like it was like the sensor module of SCANeR Studio. Start the simulation. And then as you can see, I have my outputs, so my list of plots with the intensity and the speed of these different plots that will be displayed directly in the simulation. So it's, as you can see, very easy. It's nothing like you don't need to launch any other type of tools. And as you can see, I have directly have access to the output with this list of plots. And as you can see, I have multiple plots because of the ghost effect and the railguard effect of my scene. Okay, and also, as we saw together, if I launch the control pad module to spy the network messages of SCANeR to see what kind of messages are sent by my sensor or AC module. If I launch again the simulation, a little bit like for the level 1, going to pause my simulation, launch, and as you can see, I have my messages in my network that will contain the different information about my list of plots. So I have the number of plots and the azimuth, elevation, distance, speed of these plots directly available in my network, in my simulation bus. And then, as you can understand, you can have access to this different information through our different API. Going to switch now to the level 3 for the radar level 3, just to show you a little bit the same, that we have can use the same vehicles and everything. I'm just going to open the other scenario that is made by default and that is provided by default to show you the result of a radar at level 3. So the scenario is exactly the same, but we will see the difference. So before we add this list of plots, now let's see what will be the output. I'm just going to go a little bit faster because we already have seen that. So I'm going to launch exactly in the same way the simulation with the module. So I don't need to launch anything else than the same module that I was launching for the radar at level 2. Takes a little bit of time because I'm on the laptop. And then as you can see, as an output, I have this Doppler map that is not in real time. So it's not a real time application. And I will say the outputs are more like, I would say, hard to analyze. So it's really the raw data that is really like the result of this electromagnetic ray tracing inside my simulation. Just before we go on the question, just to let you know that it's like always with all the other packs with this Physique-based sensor pack. It means that you can really use it in addition of other packs. So you don't need to use the AD-ADAS pack if you want to use the Physique-based sensor pack. You don't need to, but if you want to have level 1 and level 2 in the same simulation, that's definitely possible. If you want to then use a Physique-based sensor, for example, a radar at level 2 on the end cap scenario, US or Euro or China, because now it's available, the US and China end cap, you can definitely do it. So this pack will very fit the environment of SCANeR Studio. And just before we go on the question, just to let you know that we have these events every week, that we are going to have new subjects that will be released very soon for the summer and for September. So do not hesitate to come to the, the next events that will be coming soon. And if you want also to try this different sensor, so level 2 and level 3, just to let you know that it's definitely possible. We have a trial version available on our website for the level 2 and level 3 radar. So if you want to give a try, it's for 45 days, it's for free. So you can just ask us on our website. And oh, sorry, I can show you on the website. You can go to the SCANeR, the free downloads here. And you have the possibility to ask for a free trial of the physical sensor at level 2 and level 3. So you can just ask us and tell us which one you want to use, and we will be very happy to send you an evaluation and to show you all the possibilities of these different tools. So thank you, and if you have any question, please feel free to use the chat.
Thank you very much, Paul, for that presentation. I see that we already have some questions asked during the presentation.
Good. Yes.
So the first one was, can I have access to the output of my level 2 LiDAR through the SCANeR API as the radar?
Yes, exactly. That's exactly the same, like the things that we have seen. So if we do the exact same simulation that we have seen with the default scenario, if we use LiDAR instead, and if we go to the control pad module to see the different messages, you will have access to the output of this LiDAR in the SCANeR Studio simulation bus. And then, as always, you can have access to this information through our different API to, for example, feed your ADAS system with this output of LiDAR at level 2.
Okay, great. Another question is that do you have some customers that use the radar level 3?
Yes, so that's like use. That's we already have one customer that use it. So just to let you know, unfortunately for I would say I cannot give you the name of the company, but just to tell you that it's a company that is a sensor manufacturer. So as you can see, for them, what is very important is to, I will say, have access to this raw output of the radar at level 3, and then they want to see how their tool chain to actually process this raw data will work. So for them, what is very important as sensor manufacturer is all this signal propagation, and to see how they can extract and how their processing treatment will work to, I would say, extract the information of this raw data. Because as a reminder, on this schema at the beginning, what is important at level 1 is what you have at the right part. So it's the object list. That's like the important part of the level 1. For the level 3, what is very important is the left part. So it's all the retracing and the pre-processing of the data to extract the correct information from this raw data.
Okay, thank you. I've got another one. So, is it possible to use different sensors at different level in the same simulation?
Yes, that's definitely possible. So, for example, if you want to have I don't know, a radar at level 2 and a radar at level 1, that's definitely possible to mix these two sensor in the same simulation. Or you can also mix a level 3 with a level 2. That's also possible. I would say you just need to have a good computer to be able to to launch these different modules, but yeah, there is no limit on which sensor you can use. You can, I would say, mix them.
Okay, great. Let me check. So, for the radar, do you have the possibility to edit the properties of the emission or reception antenna?
Yes, that's possible. We have seen it, I think, in the video, so you can edit, I would say, a kind of independent way, the properties of the emission antenna and the reception antenna. That's definitely possible to have different properties for the emission and for the reception antenna. You can like tune them as you want.
Okay. Do you take in account some effects like the accumulation of water on the sensors or some other weather effects?
Not for the moment. It's something that we know it's a kind of hot topic. We are aware of it. So for the moment, we don't take into account this kind of parameters. For example, the dust on the radar will not be taken into account, for example. So we are not reaching this level for the moment, but it seems that we have more and more these requests. So it's something that we are aware and that we will try to work on if it's very important for your application.
Okay. I've got another one. So, what is your main advantage for your solution?
That's a very good question. That's a very good question. I will say we don't have only one main advantage. We have a lot of them for this different sensor. So first of all, the fact that and I hope it was clear during the presentation, because we have this level 1, this level 2, and this level 3, we really cover a lot of different applications that you could have with your sensor. Depending of what you want to do, you will use the level 1, the level 2, or the level 3, but we can really cover, I will say, a lot of different applications directly inside SCANeR Studio. So you don't need to use any other type of tools. Everything is directly included inside SCANeR Studio. On top of that, you also have the possibility, and because it's really important for the level 2 and level 3, to really, I would say, modify and characterize your scene directly from the terrain mode of SCANeR Studio. So it's a little bit linked to the fact that everything is fully integrated inside SCANeR Studio. And also, I would say the two big advantages, but they are very linked to Oktal SE, is this ray tracing engine, which is very, I would say, accurate. And because, as you can see with the different clients that that Oktal SE have, really, like, it's an engine that is really, I would say, recognized in different fields, and also because we have the experiences of Oktal SE that have worked in different domains. For example, for the military, for the train, they have a lot of experiences for different fields. And now what we are doing right now, it's bring all these experiences in the automotive world and in the automotive simulation. So I would say that our main advantage is a little bit a mix of all these different advantages. And I think our solution is pretty unique on the market. And I think the best to understand that will be maybe to try it and to give a try to see how it works and all the possibilities that are offered thanks to this physics-based sensor pack.
Okay, thank you, Paul. I've got another question in the chat. So, can I extend the sensors models by myself with custom codes?
When you say extend, that could be interesting to understand. I mean, if it's extend means if you want to use your own parameters and everything, yes, because you have access to this fully parameterization of your sensor. And also because like we saw, you have the possibility then to kind of interact, if I can say it like this, with the output of these different sensors. So after that, you can put your own system, your own signal processing, or your own ADAS system at the other part of this output to do what you want to do with this output.
Okay, thank you. Can you tell us more about the camera sensors level 2?
Yes, so like I mentioned, the camera sensor level 2, it's a little bit different from what we have seen today with the level 2 real-time physics LiDAR and LiDAR and the full physics-based radar. Because first of all, it's integrated by default with the foundation pack, and also because we don't use the different, I would say, tools of Oktal SE. We are using the fact that the Unreal scene with the Unreal Engine, you have different properties, and you can edit the properties of the scene. So I will say that this level 2 camera is a kind of a light level 2 camera. So yeah, that's a little bit a special, a little bit different than what we have seen more into details today.
Okay. I've got another one. So, does the real-time radar model also work with pedestrian detection?
Yeah, that could work. That could work. So I'm not sure if we have a pedestrian that is fully characterized in the resources. So maybe it's something that you will have to do like by yourself, or you can also, of course, ask us to do it for you as a service. But yeah, you could we could take into account not only the vehicles but the different other, I will say, actors of your simulation.
Okay. So, For the moment, I don't see any more questions into the chat.
That's perfect timing because the event is going to end up soon. But like we said with Ludovic, if you have any question, you can ask them on the chat. And if we didn't have the time to come back to you, we will send you an email, a follow-up email to answer your question. And if you have any other type of question, or if you would like to request a trial version, you can send an email to the different people at AV Simulation. So you can send me an email, or you can also send an email to your, I will say, sales manager from AV Simulation. And if you have any other question, topics that you would like to discuss, we could also organize a more, I would say, dedicated meeting to see what are your needs and how we could answer your needs on these different topics. So thank you everyone for joining, and I hope we will be in touch on this different topic very soon. Thank you and have a very nice day, and thank you Ludovic, and thank you Pierre-François for your help on this different subject.
Thank you.